Welcome back, everyone. Today, we're taking a deep dive into something pretty amazing. Uh, well, maybe not amazing exactly, but definitely important: childhood neurological disorders.
It's a fascinating area.
It is. And you were nice enough to let me borrow your old medical school notes.
Yeah.
Don't worry, I didn't spill coffee on them this time.
Laugh slightly. That's a relief. I'm glad they can be helpful. I see you've got sections marked on febrile seizures, hydrocephalus, and even cerebral palsy. Those are big ones.
They are. And honestly, before digging into this, I don't think I realized how common some of these conditions are. Like febrile seizures, I've definitely heard parents talking about those. Oh, my kid had a fever and then started seizing, but I kind of thought it was rare.
You're not alone in thinking that.
Yeah.
Febrile seizures are actually much more common than people realize, which is why it's so important to understand them.
Right, so let's jump into that. Your note said something like 2 to 5% of kids experience these seizures, usually between 6 months and 3 years old.
That's right. It's a surprisingly high number, and it often catches parents off guard because, well, fevers are so common in those early years. And they can be really scary for parents to witness.
Absolutely. So, what's going on in the brain during one of these seizures? Your notes mentioned something about a car alarm analogy.
It's a good way to think about it. Basically, a febrile seizure is like a car alarm going off in response to a high fever. It's the brain's way of reacting to that rapid temperature spike.
So, it's like the fever is setting off a sort of electrical storm in the brain.
Exactly. And just like a car alarm, it's jarring and attention-grabbing, but it's usually over quickly and doesn't cause any lasting damage. The key is differentiating it from other types of seizures.
And you mentioned boys are twice as likely to experience these febrile seizures. Any idea why that is?
You know, the exact reasons are still being researched, but it probably has to do with a mix of genetic factors and the way boys' brains develop in those early years. They tend to grow a bit faster, which might make them a little more susceptible to those fever-triggered electrical storms.
Interesting. So if these seizures are usually harmless, what's the most important thing for parents to know? What can you tell those parents who are understandably freaking out when this happens to their kid?
The most important thing is reassurance. It's totally normal for parents to be terrified when they see their child having a seizure, but in most cases, febrile seizures are short-lived and don't have any long-term consequences. Most kids who have a febrile seizure don't develop epilepsy or have lasting problems. The key is getting them the right care and ruling out any other underlying issues.
So basically, stay calm, get the fever down, and don't panic.
Exactly. It's all about getting the right information and support during those stressful moments.
That makes sense. I get it. Okay, so let's move on from seizures for now. You've also got some notes here about hydrocephalus, which sounds a lot scarier. It's like water on the brain, right?
Well, it's a bit more complicated than that, but essentially, yeah, hydrocephalus involves a problem with the cerebrospinal fluid, the CSF.
CSF, right, the fluid that surrounds the brain and spinal cord acting like a cushion.
Exactly. And it's constantly being produced and reabsorbed to keep the pressure balanced. Hydrocephalus happens when that balance gets thrown off and too much fluid builds up.
Oh, so it's like a plumbing issue in the brain.
Kind of. Imagine a clogged drain in your sink. If the water keeps flowing but can't drain properly, it's going to overflow, right? Similar idea with hydrocephalus, the excess fluid increases pressure inside the skull, which can be dangerous.
Especially for babies and young kids whose skulls are still soft and forming.
You got it. That's one of the reasons early detection and treatment are so important, that increased pressure can actually damage the developing brain if it's not addressed.
Makes sense. So, what causes this clog in the first place? Your notes mentioned a bunch of possibilities.
Yeah, the causes are surprisingly varied. Sometimes it's a birth defect, like a problem with how the CSF pathways formed. Other times it's something that happens later, like a brain tumor blocking the flow, an infection causing inflammation, or even a head injury.
So, it's not just one thing that can lead to hydrocephalus, it could be a whole bunch of different factors.
Exactly. And it's a good reminder that the brain is incredibly complex and interconnected. In fact, one of the articles you flagged mentioned a link between hydrocephalus and a condition called myelomeningocele, which is a type of neural tube defect, something we'll probably talk about later.
Oh, yeah, I remember seeing that. It's like one problem can sometimes lead to another.
Sometimes, yeah, which is why taking a holistic view of a child's health is so important.
Okay, so with hydrocephalus, we've got this potentially dangerous fluid buildup. What do you do about it?
Well, the most common treatment is surgery. Specifically, a procedure to insert something called a shunt.
A shunt, is that like a little tube or something?
It is. It's a thin tube that gets surgically placed in the brain to drain the excess fluid, usually to the abdomen where it can be reabsorbed into the body. It's kind of like creating a detour for the CSF to bypass the blockage.
Ah, so it's like installing a new plumbing route.
Exactly. And for many kids with hydrocephalus, shunts can be literally life-changing, allowing their brains to develop more normally. But like any surgery, there are potential complications.
That's what I was just thinking. There's always a but.
Right. Your notes actually mentioned one of the biggest risks: infection. It's a concern with any implanted device, and it's something doctors watch very closely, especially in the first few months after surgery.
So it's like you're fixing one problem, but then have to be really vigilant about other potential issues.
Exactly. It highlights just how delicate these interventions can be and the importance of ongoing care and monitoring for kids with hydrocephalus.
I'm getting that message loud and clear. Okay, well, this deep dive has already been full of surprises. Ready to tackle cerebral palsy next.
Bring it on. It's a condition with a lot of misconceptions, so let's clear those up.
All right, cerebral palsy, fire away. What are the biggest misconceptions?
I think people have heard the term, but they don't really get what it is.
Yeah.
Like they picture someone in a wheelchair, maybe, but it's way more than that.
Yeah, my understanding was always pretty limited too. Your notes actually define cerebral palsy as, hold on, let me find it. A spectrum of motor disorders arising from brain injury.
There you go. A spectrum. That's the key thing. It's not one specific condition, but a whole range of ways that movement and coordination can be affected.
Right, so someone with cerebral palsy might have difficulty with walking or using their hands or speaking clearly or any combination of those things.
Exactly. And the severity can vary hugely, too. Some kids might just need a little extra help with physical therapy, while others might require lifelong assistance.
It's amazing how much variation there is, and I was struck by how many different things can actually cause cerebral palsy too. It's not always obvious, is it?
Definitely not. Your notes mention prematurity, infections during pregnancy or early childhood, problems with oxygen supply during birth, even head injuries or abuse, which is awful to think about.
Yeah, it's heartbreaking. And it makes you realize just how vulnerable the developing brain really is, especially in those first few years of life.
Absolutely. And that's why early identification and intervention are so important. The earlier you can start therapy and support, the better the outcomes tend to be.
So, what does that support actually look like? If a child is diagnosed with cerebral palsy, what happens next?
Well, it really depends on the individual child and the specific challenges they're facing, but it's always a team effort. We're talking doctors, therapists, educators, and of course the child's family all working together.
That multidisciplinary approach seems to be a recurring theme in pediatric neurology.
It makes sense though, right? Because these conditions affect so many different aspects of a child's life. So you might have physical therapists helping with mobility, occupational therapists working on fine motor skills, speech therapists addressing communication difficulties. It's all about maximizing the child's independence and helping them reach their full potential.
It sounds like such important work, but also incredibly demanding for both the professionals and the families involved.
It definitely takes a village, that's for sure. But the rewards can be huge. Seeing a child make progress, even small steps, is incredibly gratifying.
Well, I've got to say, this whole deep dive has been an eye-opener. I feel like I've learned so much about these conditions, and I'm sure our listeners have too.
Me too. It's amazing how much there is to know about the brain, especially the developing brain. And the more we understand, the better equipped we are to support kids and families who are facing these challenges.
Exactly. And I think that's a perfect note to end on. Knowledge is power, as they say. So, to everyone listening, thank you for joining us on this journey into the world of childhood neurological disorders. We hope you found it informative, thought provoking, and maybe even a little bit inspiring. Until next time, keep those brains buzzing.